let's try to solve this very nice geometry problem. We have two identical squares. This is one of them, and then this is the other, right? And this point O is at the center of this square, right? And we know that the overlapping area of the two squares is 5, right? So how can we find the area of one square, right? How do we find the area of one square? So how are we going to solve this problem, right? So we have no idea what's actually, so it looks like this square is actually rotating around this corner, which is also the center point of the other square, right? But we have no idea what's actually the angle this square is actually rotating through, right? It's not telling us. So how can we actually find out what's gonna be the area of one of the squares, right? So there are different ways of solving this problem. So I'm gonna talk about um, uh, two simple ways, right? One of the ways is by cut and paste, basically. So you can try to connect these two points, right? Right, that's one point, one line, right? And then try to connect the other the other line by doing this, right? And then you can try to prove that this triangle is actually the same as this triangle, right? Why is that, right? Because this is a square, so this is a center. If you connect this center point with the corner points, right, and then these two lines are going to be the same, right? This is one side of this triangle, and then this is another side, the corresponding side of this triangle, right? So and then you can try to find um, this angle. This angle is actually the same as this angle, right? Why is that? Because this is a square, so this angle is going to be 90 degrees, right? This angle is going to be 90 degrees, and this angle is made up of this angle and the angle in the middle, this angle, right? And then because this is a square, so this is a right angle triangle with two sides equal to each other, right? So this angle is also 90 degrees, right? And then this angle is actually made up of this center angle with this angle, right? So this angle plus this center angle is 90 degrees, and this angle plus the same center angle is also 90 degrees. So this angle is actually the same as this angle, right? So you have this side equal to this side, this angle equal to this angle, and then all we have to do is to prove another condition, right? Maybe this angle, right? Is this angle the same as this angle? Yes, it is true, right? Because this is a right angle triangle with two equal sides, so this angle must be 45 degrees, right? So if this is 45 degrees, then this is 45 degrees, right? And then because this is 90 degrees, so this is 45 degrees, right? So two angles are the same, one side length is the same, so these two triangles are identical, right? So if we move this triangle over here, then we make up 1/4 of the square, right? That's 1/4 of the square, right? And this triangle is the same as this triangle, and then the whole area of the whole overlapping area is 5, right? So if we move this triangle over here, the whole area of this right angle triangle is also going to be 5, right? And what I was just saying, that this is just 1/4 of the whole square. So the whole area of the square is going to be 5 times 4. That's going to be 20, right? So the area of the square is going to be 20, right? But that's just one of the approaches for cut and paste, right? You can also solve the problem by doing another cut and paste. So instead of connecting the two points, we can draw a vertical line in the middle, and then draw another vertical line, a horizontal line in the middle, right? And in that case, what we have to do is to actually prove that this angle, this triangle, is going to be the same as this triangle, right? And you can think about the why, right? It's provable, and it's not so hard, right? These two triangles are going to be identical, and then you can still use this, arrive at the same conclusion. So it's going to be 20.